I'm building a harmonic drive mount. Why? Because I want to. Now, I have these harmonic drives. They are the HBK17. They are 1 to 100. So I'm using those. I have 2 of them. And then I'm using these NEMA 17 high torque stepper motors. Now, what I'm currently doing is I'm prototyping. So this is plywood. Now, I'm going for, how do I explain this? A 2-box design. So, 2 box, and then the telescope will be up here, and so on and so forth, like that. So that's what I'm going for. I'm prototyping with 1 box because if this fits, I can just duplicate it, copy it. Now, I am using this. This is my wedge. It is a Skywatcher wedge. From what I can feel, feels very stable. And then this will attach to the bottom, the center of the tripod, and then I'll have my mount. I might off put it like that, just so there's less like weight going this way. So I might do something like that. Hopefully, thankfully I'm not at that stage yet. I'm prototyping. So this will be one axis, this will be the deck, I believe. And it's going to be something like that. So that, and then I'll have my stepper motor. I have these little stepper motor brackets, which I'm going to use somehow. Something like putting them on like this. I'm not really sure yet. I'm just prototyping. So let's get on with it. Apologize if the air is loud. This is how it will be mounted onto the wedge. I did decide to go, I don't know how well you'll be able to see this, I did decide to bring it quite far forward just because more of the weight will be closer to this end, so it will be, and even with wood right now, like this is very sturdy. Like I feel zero play, especially in here. I was a little worried. Like I feel nothing. But yeah, I mean you get the idea. The harmonic will be like that, strain wave, and then the other box will be sitting, if I can do this with one hand, like this, and then the telescope will be up there. That is the general consensus right now, at least. So let's do it. So this might be a bit hard to explain, but this is the prototype. I'm not building the other 4 sides because I already know 5" by 5" square is what I want to go with. I already know the measurement of this hole. This one's too big, and then I just have to duplicate this one and make some custom, so they'll focus, custom brackets to raise that about to there, which I'll do out of aluminum. But this is going to go in here. And the reason I'm going to make the custom brackets is so when I mount the other box, because the screws are back here, it's going to sit a tad bit further out. Not too far, but just about to here, which is about, give or take, 8 mils. So I'm just going to get, some aluminum, make it, and then bolt the other box to that. Now, the trickier part is the stepper motor. So if you're looking to get a stepper motor, this is the stepper motor. You can pause it. I'll show you the drives too if it'll focus. I don't know if you'll be able to see the code up there, but it's, yeah, there it is. So that's the drives. But these, because I'm using belts, have to go in like this. So it's kind of hard to show you. If I can hold, let me actually do this. So I can hold it. So these motors, I have to get it in like this. So that's all good and well, but I am using these L brackets. They're just NEMA 17 L brackets. So it mounts on like this perfectly. But then I have to mount it like this on this side, which it's almost taking up the whole area, like distance. But then when I put the gear in there, it's perfect. Like I don't know if you can see that spacing from here to here, but it's pretty much perfect. And if worse comes to worse, I can always trim down this side of it, just like cut it here or something, and then just bolt it. But other than that, there's not really much more to be done. I mean, I have all the measurements. I have where it's being bolted. This hole's going to be smaller because if you look at it, it's a bit of a loose fit. This was just for prototyping, but this is, I don't know if you'll be able to see this. About 63 mils. 64. Yeah, so I got a 64 millimeter drill bit to bore out a hole. And I also got one for here, about 45. So it should give me 0.2 mils of clearance, which is pretty much all I need for this. And then that is pretty much all the prototyping I'm doing. I might make like a cross beam down here to go across here because this is just mounted here and it's about an inch wide, so I might put something under there like this so it has more surface area this way. I haven't really decided on that yet, but this pretty much is the final template. I just gotta order aluminum, I gotta get the drill bits for the holes, and then really I should be able to start building it out of aluminum. And then what's one thing else I have to do? For the dovetail, I don't have it down here, but I have to create a custom bracket. So I have to create a ring around here, and I have to put 4 screws in. And then it has to come above here a tad, and then I have to be able to get screws in from the back. So this way, and just have a solid plate here so the dovetail can sit on here. I have to do the same thing for here, for the other box that's going to go on here, just to space it out a tad bit more. So I think this should work out good. The total gear reduction is 400 to 1 with the pulleys and everything, which I will have to do a little modification, get it to fit into here. And yeah, it should be perfectly adequate for what I'm using it for, and I'm quite excited.